In this video, we're going to learn how to do molar mass calculations and mole conversions with compounds, meaning ionic compounds and molecular compounds. So please title your page in your journal, Compound Molar Mass and Mole Conversions. We're first going to review what we already know about moles. Please record this in your notebook as well. We know that 1 mole of any element is equal to 6.02 times 10 to the 23rd atoms of that element. So for example, if I'm given 0.52 moles of carbon and I'm asked to solve for the number of atoms of carbon in the 0.52 moles of carbon, I'm going to use this known conversion factor that 1 mole of carbon equals 6.02 times 10 to the 23rd atoms of carbon. So I have my given, I have my want, and now I'm going to use dimensional analysis to convert the 0.52 moles of carbon into atoms of carbon. So remember, in dimensional analysis, you start with your given, you put it over 1 as a placeholder, and the whole thing about dimensional analysis is you want the units to cancel. Since my given unit is moles of carbon, I'm going to have to copy down that given unit down and across so that the units are going to cancel. This next column is going to contain our conversion factor, which is our highlighted conversion factor up here. I know I have to put moles of carbon on the bottom, and notice that the number in front of mole is always going to be a 1 in this conversion factor. So 1 mole of carbon goes on the bottom, and what it's equal to goes on top. So the 6.02 times 10 to the 23rd atoms of carbon will be on the top. And so this second column represents that conversion factor. 1 mole of carbon equals 6.02 times 10 to the 23rd atoms of carbon. So moles of carbon cancel. You got 1 on the top, 1 on the bottom, and the unit that you're left with is atoms of carbon. That's your wanted unit. So now I stop, I pick up the calculator, and I calculate, remembering to multiply the top row, then multiply the bottom row, and then divide the top by the bottom. So it'll be 0.52 times 6.02 E23, enter, and then on the bottom all I have are 1, so I really don't have to do that division. My final answer will be 3.1304, and then that E23 in the calculator gets converted onto my paper as times 10 to the 23rd power. One last thing, let's check for our sig figs. We have 2 sig figs in our given, so our answer is going to contain those 2 sig figs. So I keep 3, I keep the 1, and those are the 2 significant digits that I need to keep. That's where I'm going to draw my dividing line. After that dividing line, I check to see if I need to round up. I do not need to round up. So my final answer is 3.1 times 10 to the 23rd atoms of carbon. What's another conversion factor that we already know about the mole? We know that 1 mole is equal to the molar mass from the periodic table. So for example, if we wanted to convert 10.3 grams of phosphorus into moles of phosphorus, I would look at the periodic table and look up the mass for phosphorus. So I'm going to take my 10.3 grams of phosphorus as our start, our given, put that over 1, and I know I'm going to have to use grams of phosphorus on the bottom. And so that means I'm going to have to put moles of phosphorus on the top, because I'm using this conversion factor right up here I'm just recopying it down here in our dimensional analysis grid. Well, now for the numbers. Well, in front of mole, I always have a 1. So I'm just copy down the 1. And then for grams, that's going to be the mass from the periodic table. So I need to pull up the periodic table and find the mass for phosphorus. Phosphorus has a mass of 30.97. So what that really means is that 1 mole of phosphorus is equal to 30.97 grams of phosphorus. Grams of phosphorus are going to cancel, and I'm left with moles of phosphorus on the top, exactly what they want me to solve for. Now I calculate 10.3 times 1 on the top, and then divided by 30.97 on the bottom. And I'm going to get an answer of 0.33258, and the unit will be moles of phosphorus. Last step, let's check for our sig figs. Our given has 3 sig figs. So that means I would like to keep 3 significant figures in my final answer. Remember, the first significant figure in a number is always the first non-zero digit. So this 0 doesn't count for a significant digit. I now start counting 1, 2, 3. I look behind. There's a 5 after our dividing line, so that means I need to round up. So our final answer rounds up to 0.333, and I just copy our units, moles of phosphorus. Okay, so now how do I apply my knowledge of moles of elements to moles and compounds? Okay, so on our right-hand side, we're going to do similar problems, except instead of using just single elements, we're now going to use compounds, which are going to be either ionic or molecular, as we've studied in our bonding unit. So now, compounds. So just like 1 mole of an element contains 6.02 times 10 to the 23rd atoms of that element, 1 mole of a compound will equal 6.02 times 10 to the 23rd particles. And really, particles is a more broad term that we use to describe molecules and atoms and ions. So really, 1 mole of anything is equal to 6.02 times 10 to the 23rd particles of that substance, whether it is going to be a compound or a pure element. So let's look at some examples. Let's say I have 1.03 moles of CO2, carbon dioxide, and they would like for me to calculate how many particles of CO2 that is equal to. So again, I have a given, I have a want. The dimensional analysis process is the same. I take my given, 1.03 moles of CO2. I can put that over 1 as a placeholder. I know I'm going to have to put moles of CO2 on the bottom. And since I'm solving for particles, particles is going to go on the top. Now for your numbers. Well, what is the conversion factor between moles and particles? It's this new one right up here. 1 mole is equal to 6.02 times 10 to the 23rd particles. And so I'm going to copy down the numbers for each one of those units. The number in front of mole is still a 1. The number in front of particles is this 6.02 times 10 to the 23rd, Avogadro's number. Moles of CO2 cancel. You're left with the unit of particles, CO2 on the top. Now it's time to calculate. Still multiply the top. 1.03 times 6.02 E23. And I just have ones on the bottom, so I don't really have to do anything with those. And our answer in that calculator is 6.2006. I take that times 23 times 10 to the 23rd. Okay, now look at your sig figs. You have 3 sig figs in the given, so I would like to keep 3 significant figures in our final answer. And so we round this to 6.20 times 10 to the 23rd particles. CO2 is your final answer. All right, how about now when we have compounds and grams? Or in other words, what about the molar mass of compounds? 1 mole is still equal to the molar mass from the periodic table. So for example, let's say I have 110 grams of diphosphorus pentoxide, and I'm asked to convert that to moles of diphosphorus pentoxide. Well, I'm going to use this conversion factor right up here. That's how I'm going to convert between moles and grams of a substance, no matter if it's an element or now a compound. Well, I need to know that 1 mole of diphosphorus pentoxide equals the mass from the periodic table. So I look at our periodic table. Phosphorus has a mass of 30.97. Oxygen has a mass of 16. Now I look at our chemical formula. There are 2 atoms of phosphorus, and there are 5 atoms of oxygen. So the molar mass of P2O5 is going to be the mass of 2 phosphorus plus the mass of 5 oxygens. So we're going to do 2 times the mass of phosphorus plus 5 times the mass of the oxygen. So it'll be 2 times 30.97 from the periodic table plus 5 times 16. And we get a molar mass of 141.94 grams per mole. So that means 1 mole of diphosphorus pentoxide equals 141.94 grams of diphosphorus pentoxide. That's going to be our conversion factor between these 2 compounds. Between these 2 units, So for our work, we're going to take our given, the 110 grams of diphosphorus pentoxide, 1 mole of diphosphorus pentoxide equals 141.94 grams of diphosphorus pentoxide. Using that conversion factor from above. grams of P2O5 cancel. You're left with moles on the top. And so now I calculate this. You're going to do 110 divided by 141.94. (0.774975). Looking at our sig figs, our given has just 2 sig figs because that last 0 doesn't count, there's no decimal point. So our final answer is going to contain just 2 sig figs. And remember, the first significant figure in a number is the first non-zero number, so you could ignore that 0. You're going to keep the 2 sevens, look behind it, there's a 4. So do not round up. Your final answer will be 0.77 moles of diphosphorus pentoxide.